Hello there. We are here in Unit 3 looking at populations, and we're going to zip through the first three topics here, looking at, as you can see, Topic 1, Generalists and Specialists, Topic 2, K and R selected species, and Topic 3, Survivorship curves. So here we go. No, just kidding. Here we go. All right, so 3.1, looking at generalists and specialists. You probably have an idea of what these are already, at least you should. But just in case, these are new terms to you. Specialists, they are species that are going to have very particular requirements. They're going to require particular, temperatures or foods or certain types of shelter. So they've got a very narrow niche. A niche is a whole range of conditions that an organism can thrive in, and specialists can only thrive in a very small niche. Excuse me. Specialists are really good at what they do wherever it is that they're living, but specialists are very vulnerable or susceptible to changes in terms of, a natural disaster. Specialists can't really bounce back from a disaster very well. Specialists tend to be the first ones that are affected, aka dying, due to factors like habitat loss and other mostly human-caused disturbances. Because they have such particular requirements, they just can't deal with change very well. And then you've got your generalists. Generalists are pretty much the opposite here of specialists. They have a very wide niche. They can utilize a lot of different habitats and foods and things like that. They can live in a variety of locations, and they're pretty adaptable. They can, they can work with whatever conditions are thrown at them, for the most part. Of course, when we think of a specialist, we tend to think of something like the giant panda, who only lives in bamboo forests, who only feeds on bamboo, whereas a generalist would be something like a black bear that you can find in so many different habitats, ranging from warm habitats like here in Florida, throughout the rest of North America, ranging all the way north into parts of Alaska, feeding on a whole bunch of different things, whether it's human garbage or things found in nature. So black bear is a good example of a generalist. This is just a graph from an old textbook, but you often see graphs similar to this. What you're looking at across the x-axis is resource use or resource consumption. The y-axis is showing you how many individuals of whatever particular species we're talking about. So you can see the red trend line is going to be your specialist, showing you that very narrow niche or very narrow use of resources. And then your blue trend line is going to be your generalist, using that wide array of resources. The two examples given in this particular graph, again, pandas for specialists, and in this case, raccoons for generalists. You do notice there is a shaded area. That's where their niches overlap. So there will be inevitable competition between the organisms for whatever resources they are trying to share. So there's going to be some sort of competition going on in that region of niche overlap. And that's pretty much it for generalists and specialists. It's really not that complex. This is right from the course and exam description, or CED, looking at the learning objective. Can you identify differences between generalists and specialists? I think you can. Can you figure out why specialists tend to be advantaged in habitats that remain constant? I'll give you a minute to think about it. Why do specialists have an advantage in a habitat that remains constant? Well, it's because they can't deal with change. Specialists cannot deal with change, so obviously they require habitats that are relatively stable, whereas generalists, they can deal with lots of changes. All right, moving on to 3.2, K and R selected species. The R here should actually be a lowercase r. But the formatting here on this slide made everything be capitalized. So just FYI. So K and R selected species. Again, we've mentioned it before, but just a refresher if you need it. Excuse me. But before we get into what they mean, these terms are just kind of broad terms referring to reproductive strategies, life history strategies of organisms. And I really want you guys to understand it's not just, I fall into this category, that's it, done. Many organisms can kind of have traits a little bit, a few traits that are K-selected and a few traits that are R-selected. It's more of a continuum. It's not going to be necessarily one or the other for the majority of, life on Earth. It's going to fall kind of in the middle into that gray area where there's a little bit of traits of both K and R selected species. So what are we talking about here with this continuum and these traits? K selected species are going to be focused on long-term survival. They're focusing their efforts and their reproductive efforts into ensuring that their offspring are not only being produced, but surviving. So it's all about survival. More often than not, K-selected species are big in size, like elephants, and they tend to have long lifespans. K-selected species, oftentimes, their population is at carrying capacity. I know carrying capacity comes later in this unit, but carrying capacity is pretty much, how many individuals a habitat can support. So K-selected species tend to thrive in stable environments. K-selected species will reach sexual maturity later in life, and because they reach sexual maturity later in life, that means they're not going to be making as many babies compared to an organism that reaches sexual maturity early in life. And speaking of babies, the offspring, the babies, whatever, are what we kind of can refer to as expensive. What does expensive mean? Well, it's referring to everything. It takes a lot of energy or expenses for an organism to, carry the baby, the gestation period, to deliver the baby, to raise the young. Raising them means producing milk if we're talking mammals, teaching them, staying with them, ensuring that they are surviving. And so that's what these expenses are. It's, the parent, more often than not the mother, putting a lot of time and effort and energy into ensuring that their offspring survive. And here's just a couple of pictures of K-selected species. Move my head. Elephants, humpback whales are a couple of examples of K-selected species. And then on the opposite end, you've got your R-selected species, which we're looking more at not so much survival, but reproduction. That's where the R is coming from, reproduction, and the K for K-selected comes from carrying capacity. So it's all about reproduction. We understand that some of the babies are not going to survive, but let's make a ton of them. And probability states that some of them will survive. Most of these organisms that are R-selected are going to be smaller in size, small-ish, and have a relatively short lifespan. They're going to reach sexual maturity early in life. They're going to live in fluctuating, unstable environments. Their populations are usually either going way above carrying capacity and then dying off. That's overshoot and die off. Rather than kind of maintaining a stable number. And in terms of babies, offspring, the R-selected species are producing cheaper offspring. Many offspring all at the same time, multiple times per year. There's no or little to no parental investment involved here. Have your babies and move on, make some more. So R-selected species, pretty much all the opposite of K-selected species. So here's a couple of pictures, again, of R-selected species. So things like sea turtles. A mama sea turtle is laying, we'll say, about 100 eggs per clutch. And out of those 100 eggs, less than one will actually survive into adulthood. And she'll come ashore and lay batches or clutches of eggs, a few times during mating season. So a few hundred eggs are being produced, or a few hundred eggs are being laid, but not many of them are actually making it into adulthood. And then insects, most insects are selected as well. Think about the times that you've seen, huge insect infestations, and then a couple weeks later they die off. That's a indicator that it's an R-selected species. So just comparing R and K selected organisms, R on the left, and then K here on the right. I'm not really going to spend much time because I pretty much talked about all of this. Pause the video if you need to. And again, like I said, it's a continuum. Some organisms are not going to fit perfectly into all the characteristics. It's a continuum. It's a spectrum. And then here's your little wrap up, all of your objectives and essential knowledge for R and K selected species. I'm going to speed through this because I'm running low on my time. I can only do 15 minutes. So we're running out. Let's go. My last topic here is 3.3 survivorship curves. What a survivorship curve shows us. It's a graph. Where's my text? It's a graph showing survivorship. How many individuals are surviving, or percent that are surviving of a given group of organisms. There are 3 types of survivorships. Type 1, Type 2, Type 3. Type 1 survivorship, like you see here, most of the babies survive. They survive into old age, and then once they reach old age, they start dying off. That's what you're seeing in that blue trend line. The orange one for type 2 survivorship, we tend to describe that more like constant decline or constant death. There's no matter if you're young, middle-aged, old, individuals are dying at a constant rate. And then type 3 survivorship, many offspring are produced. Of those many offspring that are produced, only a handful survive into adulthood, but those that do survive into adulthood will last a long time. So you can kind of correlate type 1 survivorship with, what do you think, R or K selected species? Living to old age, low death rates. They're probably living to old age because their parents were taking care of them when they were young. So type 1 is often correlated with K selected species. Type 3 is often correlated with R selected species. Lots of babies, not many of the babies are surviving. So that is a trait of an R selected species. And then type 2 doesn't really fit either of them very well. College Board likes to ask mostly about type 1 and type 3. So yeah, those are survivorship curves. I don't know what else to add to survivorship because it's really not that much. So there's your learning objective and your essential knowledge for that topic. Ignore the crypto thing at the bottom there. That's from a template I was using for this PowerPoint. I think that's about it. So if you have any questions, please reach out to me, and I will say ta-ta for now. Adios.